So the problem we have here is another limit, but this one involves a square root. The main idea for this one is the idea of using the conjugate. Now a conjugate is something we've seen before, but kind of in a different way. We all know that a squared minus b squared factors to a minus b times a plus b. Well, these two are conjugates of each other. All a conjugate means is that you negate the second term. So if the second term is negative b, the conjugate makes it positive b. If the second term is positive b, the conjugate makes it negative b. So what we're going to do is we're going to flip this around and say a minus b times a plus b. Well, if we wanted to, we could now figure out a way to square these. So a minus b times a plus b gives us a squared minus b squared. So that's a really easy way of canceling out what we see as this square root. So here we do need to go ahead and check plugging in 5. Well, obviously x minus 5, 5 minus 5 in the numerator is going to be 0 in the denominator. 5 plus 4 is 9. The square root of 9 is 3. And 3 minus 3 gives me 0. So I've got limit x goes to 5 of x minus 5 over the square root of x plus 4 minus 3. Now the goal here is to cancel out the square root. So this is the side, whatever side has the square root, that's the side we're going to be looking for the conjugate. For a conjugate, we need an a and a b. So here I have a minus b. So what I need to do is I need to multiply by a plus b. A is just the square root of x plus 4, and b is just 3, and I have to add them. Now we can't just multiply on the bottom, we do have to multiply top and bottom. So multiply the top by the same thing, x plus 4 plus 3, and that is because when we multiply by this, we're essentially multiplying by 1, and so we're not actually changing the value of our function. So now limit x goes to 5. In the numerator, we're just going to put these two together. We're not actually going to expand or combine them. X minus 5 times square root x plus 4 plus 3. In the denominator, though, when we multiply a minus b times a plus b, we do end up with a squared minus b squared. My a term, again, is root x plus 4, so this is root x plus 4 all squared. Minus my b term is 3, so that's 3 squared. Now I've got this combined into one fraction. I'm going to go ahead and simplify it. Limit x goes to 5. Still in numerator, x minus 5, and then the square root x plus 4, don't need a parenthesis there, plus 3. Now in the denominator, the square root of x plus 4 squared, that's just x plus 4. The square root and the square cancel each other out. 3 squared is 9, so minus 9. And now we can start to see that down here we may be able to really simplify some stuff. But you might be thinking, why do I have parentheses here? It's always important to put parentheses right after you do something and then decide later if you can take them off. So we have limit x goes to 5, and up top stays the same, x minus 5 square root x plus 4 plus 3. And in the denominator, I don't need these parentheses because there's nothing in front to multiply by, so it's just x plus 4. The negative of 9 is negative 9. And now simplifying further, limit x goes to 5. I've got x minus 5 square root x plus 4 plus 3. And x plus 4 minus 9 is x minus 5. And now hopefully we can see where our cancellation is. I have an x minus 5 at the top and an x minus 5 at the bottom. Now it should be pretty obvious if you got overzealous up here somewhere and you decided to combine the x minus 5 and the root x plus 4 plus 3, you probably wouldn't recognize that there is that x minus 5 in there that you can cancel out. Now, because x is going to 5, it is obviously that x minus 5 term that's causing us to go to 0 every time. So now our new limit x goes to 5 of the square root of x plus 4 plus 3, and my new denominator is 1. Substituting now, 5 plus 4 gives me 9. 9, the square root is 3. 3 plus 3 is 6. And 6 over 1 is just 6. So my final answer, limit x goes to 5 of x minus 5 over the square root of x plus 4 minus 3 equals 6.